So for this lecture, we are going to talk about standard deviations, and so we can see what the variability in scores are for the Rahi stress scores. And to begin with, let's move the Rahi stress scale over to its own sheet. So add another sheet, call it the Rahi stress. Rahi stress scale. We'll go back to our data because it just gets messy after all with all this information on your stress scale. So if you look at this, we have these three columns that we want to copy over. So highlight this one, and this one, and we'll go down, get all our information that we have. Right click, copy, and then we'll go to the Rahi stress scale, and we will paste. Now you see this has a reference number on it. We really don't want those numbers because those are the resiliency scale. So we will highlight those and hit delete. Remember, we just we needed these ones. That's why we took and copied the whole column. We do want to have the consistency of the participant numbers. So go back to your validation, to your data sheet, and copy the IDs all the way down for all your, oops, I didn't get all of them, so let's do it again. Copy, go back to the resiliency scale, and let's paste them here. Here, now we have our participant numbers, the stress scores, and the stress categories. We have the mean, the median, the mode. We have the different categories. So we can go back to the data sheet. Now we can clean up this and get rid of this. Just delete. This is all nice and clean now, and we can then continue on to here. We won't make so much messes with things. But we're going to try to figure out on the bell curve, how many people fall within the 68th percentile, which is the 68% of the population. That's where most of the scores fall. That's usually most 68% of scores fall within one standard deviation. And we want to find out how spread out are these scores. They don't look like they're spread too far just from these numbers, but let's start with standard deviations. So we're going to go with, we'll just type in SD. And here we're going to go equals and start typing in standard. Actually, it's STD, and you will find STDEV.S. That is the standard deviation for a sample. It's not my population, but it's the sample since we have a sample of students. So standard deviation for sample, tab, and it's going to ask you for the range of numbers. So we're going to go into the scores, not the categories, but the scores, and we're going to hit enter. So the standard deviation is 137.2358. I don't like all the numbers behind the decimal point, so I go up here. On this up here, you can either add decimal points or you can subtract decimal points from your numbers. I usually like to work with no more than 2 decimal points for my data. So now you remember, if you watched the video on standard deviations, you have 68% of people that fall within one standard deviation, and then you have 5% that fall outside of that, so 95% fall within 2 standard deviations, and 99 fall within 3 standard deviations. So we are going to find out, where do these scores fall? Are the students within 1 standard deviation, or are they 2 standard deviations out, or are they 3 standard deviations out? So here we're going to put 68%, and 95%, and 98, 99%. Now to calculate how many people fall within the 1 standard deviation range, remember that we have 1 standard deviation is from the mean goes up, or 1 standard deviation goes down. So what is the 1 standard deviation below minus standard deviation? Then we have the mean, then we have plus standard deviation. So to calculate the 1 standard deviation below the mean, type in equals the mean, this number, minus sign the standard deviation. Enter. I'll do that again. Equals, click on the mean minus the standard deviation. So the low end of 68% is 145.39 points. And the high end of this, let's calculate that, equals the mean plus 1 standard deviation. Enter. So now we can tell that 68% of the students have a stress score between 145 and 419. That's where most of the students fall in this sample. Again, yours will be different because your numbers that you're working with are different. So you wonder, okay, so we had some people that were outliers of 419. So we have a lot of people that were in a higher category. You wonder how many people actually are significantly different. So remember, 95% is statistically significantly different. Let's find out who falls outside that category. So here, minus 2 standard deviations now equals the mean. And to be able to do this, we have to use parentheses, but the mean minus, then we have to put it into parentheses. So the mean minus parentheses 2 times is the little star. So 2 times the standard deviation, parentheses, enter. I'll do that again for you guys. So equals the mean minus parentheses 2 times the standard deviation, end parentheses, enter, and plus, you're going to do the same here, equals the mean plus parentheses 2 times the standard deviation, end parentheses, enter. So if you have any scores, we did not have any scores that were 8. 98 was our lowest, 72. Yeah, so 72 was my lowest score. You can look and see. So we don't have anybody who falls below. So nobody has super low stress. But we do have some that fall significantly higher than 2 standard deviations. So let's find out who scores higher than 2 standard deviations above. We don't have to do the 99 below, or the 2. We don't have to do 3 standard deviations below because there's no score lower than 8 in the data. But we can definitely find out what is the score for a high standard for 3 standard deviations above the mean. So equals the mean plus, oops, got the wrong, plus parentheses 3 times standard deviation, and parentheses, enter. So do we have anybody who falls over the category of 3 standard deviations above? Let's look, which are 600 plus is what I had, 703. So we have one individual in this cohort that was statistically significant to the P. You will see the P is less than 0.01. This would be P less than 0.05. This is where you land if we are statistically significantly above the 5%, the 95%. So 5% of the population will fall outside that, and 1% of the population will fall above this number in our scores. So we can see somebody is really, really different. We have a few people that are significantly different, but only one is at the 1 percentile different from the rest of the group, or significantly different. So that is how you do your standard deviations to find out, is my population, do they fall within the average, within the mean, 1 standard deviation? Are they significantly different at 0.05? So are they 5% difference from the rest of the population? Or are they even more significant, or they're 3 standard deviations and they're outside the 99% of the population?